Welcome to Academic Digest class. Today we are going to be treating half-life of a zero-order reaction. So, how to find the half-life. And for us to do this, we need to remember that we've derived the integrated law, rate law for zero-order reaction. So that is what we use. Check my video on rate law. So whenever you're doing this, you need to know that this concentration is simply the concentration for a given time. And when you're talking about life, it simply means the time, half-life, the time for this particular concentration at a given time to get to the half of the initial concentration. That is, the initial concentration can be, let's say, 50 or 40 or whatever it is. So the time for that initial concentration to get to half of it to disintegrate, because you know that in concentration decreases. So in rate of reaction, you need to know it that as you progress, the rate of reaction tends to get to a point where everything disappears. It keeps reducing. So from the initial concentration down to the part where it gets to half. So for that reason, anytime I'm doing half-life of a reaction, I will always convert the concentration at a given time to initial concentration all over 2. So this is equals to minus KT plus initial concentration. So if I know this, let's say I put this to this side, because remember that the goal for half-life of a zero reaction is how do we find this thing, because the minute we make this to be over 2, this means that this is time for this to get to half. So if I know that, it simply means that I need to make T subject of the formula. So this now becomes initial concentration over 2 minus initial concentration is equals to minus K T half. So anything standing in this way is on this one, so over 1. So I have 2. So I have A concentration, initial concentration, 2 into this is 1, so times this, bring it down. So 2 initial concentration goes to minus KT half. So you can see that this is going to be the sentence in A naught minus 2 A naught, becomes minus A concentration, initial concentration all over 2 equals to minus KT half. You've seen it. So that means I have minus here, I have minus here. Let the minuses take care of themselves. So I have A naught over 2 equals to KT half. You can see that I can now carry K and come here. That is divide both sides by K. So I have divided by K. Then this one divided by K. I want you to get it this way, because if I come and put this, you might think I'm divided by fraction. There is difference between when I have A over B over C. This is more like A being divided by a fraction, and there's difference between A over B divided by C. So that is why I'm going to leave this way, to show you that everything here is being divided by this K. So which is the sentence as saying that K is standing on its own over 1. So this is going to be the sentence as saying 1 over K times concentration of A naught over 2 is equals to, this will cancel this, so I have T half. So this is going to be A naught initial concentration all over times this is going to be 2K equals to T half. So for a zero order reaction, the half-life of a zero order reaction is simply given by initial concentration all over 2 multiplied by K. That is the answer. So this can also be written as T half equals to A naught over 2K. So whichever way you want to get it, you can still write it this way.